Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 13, Lesson 1. We will be studying area. When you are in 2nd and 3rd grade and you study area, and that again is talking about two-dimensional measurements, you often use grid paper like the one over here in number 1. Because we call the units that we express area in of measurement, we call them square units because they are literally squares. And so our starting place is really understanding what that might look like in a picture. Now hopefully if you're looking at number 1 down here, rectangle A looks a lot like an area model, doesn't it? It's got 1, 2, 3, 4, 5 rows and 1, 2, 3, 4 columns, which reminds me of 5 times 4. But when kids are young, their starting place will be to count them all. So let's see, there are how many rows of 1-inch squares? They're getting the inches from the scale right up here, and they will tell you that just like on a map scale. So there are 1, 2, 3, 4, 5 rows, and each row has 4 1-inch squares, so there are 20. And you could actually count them all out and see that. But as we mature, we can get more and more abstract. So the example over here is an area model, like we've used in multiplication and division, where they don't show you every square. They assume that you understand that they could really be there. So here we have a rectangle that is 2 feet up and down and 8 feet across. And that means that it would have 2 rows of 8 squares, or 8 rows of 2 squares. And it really doesn't matter what order you do them in. It's your choice. So the area of rectangle B is equal to the length times the width. I always prefer to think of it as the height because it looks like it's going up and down to me in the picture. You can use whatever dimension words you want. So the length here is 8. The width that they give us right here is 2. And 8 times 2 is 16 square feet. So here are our feet, and they've got a little tiny exponent floating up in the air there. That 2 means that we are operating in 2 dimensions. The linear measurement right here of the length is a one-dimensional measurement. It goes in opposite directions forever and ever without stopping. That's the first dimension. But the squares not just go side to side, they also go up and down at the same time. So that tells us we're in the second dimension. Here we have another example where we can see the squares laid out for us. If the area is the length times the width, well, this is 2. And what they call the width up and down for me is height. That's 3. So here we have a rectangle that has 6 square centimeters in it. On this one again, they're being a little bit more abstract. 3 times 7 is 21. And that's because there are 3 rows and they each have 7-inch squares in them. Ooh, this one has 9 rows of 2 squares in square feet. So 9 times 2 is 18. And here we see all of your multiplication coming together with area models, coming together with geometry. Another fun thing we get to do here in this unit is to estimate area for things that are not exactly so. Now they're going to start off pretty simple. And let's look at these pictures down here. You can see that mostly these are lining up, but not 100%. So we have to be a little canny about this, a little wise. If it's all the way colored, we're going to count that as 1 square unit. If it's clearly half, we'll count that as half. But if it's mostly covered, just a little bit of it is not shown, we'll count that as 1. And if it's mostly not covered, just a little bit of it is shown, we'll count that as 0. So let's see what's going on right here. Well, first I'm just going to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got 10 full ones. What about ones that are half? You know, the first time I looked at this unit, I thought, oh, that's a half unit. But now that I look at it, it is not a half unit, is it? But it's mostly colored in. It's more colored in than less. So we're going to count that as 11. This one over here looks like a congruent shape that's been rotated. Count that for 12. This one is mostly colored in. We'll count that for 13. And this one also, we'll count it for 14. Now, this part right here, this square, it's less than halfway colored in, so we're just going to count that as 0. And this one here, it's also less than halfway colored in, so we'll count that for 0. So I'm estimating that this is going to cover, this has an area of 14 units, and they just say units there because they could be any kind of square, squared, that 2 letting me know. I think the green one might even be easier here because these two make 1 and these two make 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this would be 17 units squared. You've got so many fun problems to play with when it comes to area. Ooh, this is another one where we get to estimate. I think I have time to do it. Yay! So we're going to use this same scale to help us figure out what's full. So what's the number of full ones here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 of those. Number of halves. I'm going to change color for that. 1, 2, 3, 4, 5, 6, 7 halves. Okay. How about the mostly coloreds in? This one is mostly. I think that's the only mostly. Is this one mostly? Oh yeah, I think that one is mostly too. That's 2. And then this one right here, it is not mostly, and this is not mostly. So that's 2 of these. So the area of the figure in square units, well, I think it's going to be 10 for the whole ones. And then I think it's going to be, it's going to be 7 halves, but that's the same as 3.5, or I'm even going to write it as a decimal, 3.5, because 5 is half of 10. Now with the mostlies there, I'm going to count that as 2. And right here, I'm going to count that as 0. So I've got 10 plus 3.5 plus 2. Well, let's see. 10 plus 3 plus 2 is 15. And then we've got the decimal here, the half is 0.5. 5 and 5, 15 and 5/10. Oh my goodness, we're using our fractions, we're using our multiplication, we're using our addition, we're using our decimals. So much fun to be had with area. Guys, your pages are 133 to 138. If it's not the summer, please visit me during my office hours if you have questions. And if it is the summer, have your parents help you send me an email so I know to get with you. I'll be trying to do that once a week all summer long. Thanks for playing area with me, guys. I have so much fun playing math with you. Bye-bye for now.